morning, we're going to start looking at the trig functions. There are generally two ways of looking at trigonometry. We have trigonometry of a circle and right triangle trigonometry. Right? Today we look at circle. Right? Take a circle of radius r, centered about the origin. Right? And we draw a line segment, a ray. Initial point is the origin, the terminal point is x comma y. Again, that line segment is going to have a length r because it's going to be a radius. Right? Radius is the same no matter where in the circle you're located. Well, that ray is going to form some angle t with respect to the positive x-axis. Here are the 6 trigonometric functions. Sine of t is y over r. Cosine of t is x over r. Tangent of t is y over x. Secant is r over x. Cosecant, r over y. And finally, cotangent is x over y. So these are the 6 trigonometric functions as defined on a circle. A lot of fun with trig comes from the properties. I would recommend maybe have a separate sheet just for the properties. Here are the first properties, the even and odd properties. Sine is odd, cosine is even. Remember, we defined what an odd function, even function were way back at the start of the semester. Fundamental identities. Tangent is sine over cosine. Secant is 1 over cosine. Cosecant is 1 over sine. Cotangent, cosine over sine. Which is also 1 over tangent. These 4 are pretty useful. Right. So if you look at these 4, which you should easily be able to see just from the definitions, right? That cosecant is 1 over sine, it's the reciprocal of sine. and so on and so forth. But what these says is, look, cotangent, cosecant, secant, tangent, those are the other four trig functions. They're all defined in terms of sines and cosines. So really, you just have to remember sine and cosine, and you get the other four. Which ultimately boils everything down to two trig functions out of the six, so all you need to remember your sine and your cosine. Now let's look at this. We know that sine is odd and cosine is even. Well, if you look at tangent, then what do you think tangent is?
Cosecant? Wait, that's what we're doing?
Now, in terms of even odd, is tangent even or odd? It's odd. It's odd over an even, which is odd. Secant, well, that should be pretty easy. Secant's even. Right, both one is even, obviously, and cosine is even. Cosecant is odd. Right, one is even, sine is odd, even over odd. And cotangent is also odd. Only cosine and secant are even, the other four are odd. Pythagorean identities. There are three of them. First one, sine squared plus cosine squared is equal to 1. Again, that should easily be derived based on the definitions. Second one, 1 plus tangent squared is equal to secant squared. This is easily derived just by dividing every term of the first identity by cosine squared. The third one, cotangent squared plus 1 is cosecant squared. That is easily found by dividing each term in the first identity by sine squared. Now the trig functions are your first look at functions that are called periodic. The period of a repeating function is defined to be the smallest number such that f of x plus p equals f of x for every value of x. And trig functions aren't the only periodic functions, but they are the most obvious. Let's see if I go. sine and cosine are 2 pi periodic. Tangent is pi periodic. And here we have the unit circle. This will be provided for you on both exam 2 and exam 3, so you don't have to memorize it. I'll probably be referencing this again during some of the questions that we do. This one's pretty important. P of theta is in a quadrant. It is said that theta is in that quadrant, right? So your point that's associated with the angle theta, if that's located in a specific quadrant, then we say the angle is in that quadrant. Create a table for the sines of each of the 6 trigonometric functions for theta in each of the 4 quadrants. Where's quadrant 1 located?
So positive.
Which is what?
Right, top right side.
Upper right. And we know both x and y are greater than 0 there. Now remember how your trig functions are defined. Right. You need your x-coordinate, your y-coordinate, and r. But r is a distance, isn't it? Distance from the origin to the point. Can distance ever be negative? No, distance is always positive. Right. Which means r is always positive, so we can really just ignore r. Then in quadrant 1, positive, positive, positive over positive, it's positive. Positive, positive, positive over positive is positive. All 6 are going to be positive in quadrant 1. Where's quadrant 2 located?
The upper left.
What do we know in quadrant 2?
Y is positive, X is negative.
And again, r is
Positive.
positive, always positive. So go back. Sine, is that positive or negative?
It's positive.
Cosine,
Negative.
tangent, secant,
Negative.
cosecant,
Positive.
and cotangent. So sine and cosecant are the only two that are positive. Everything else is negative. Where's quadrant 3?
Bottom left.
And what do we know in quadrant 3?
Both is negative.
And once again, r is always positive. What's sine?
Negative.
Cosine?
Negative.
Tangent?
Negative.
Yeah, it's positive.
Positive, right? It's negative over negative. Secant?
Negative.
Cosecant?
Negative.
Cotangent?
Positive.
Quadrant 3, tangent and cotangent are positive, everything else is negative. Oh, this one's going to be tough. Where's quadrant 4?
Bottom right.
Process of elimination now, right? What do we know in quadrant 4?
X is positive, Y is negative.
What's sine?
Negative.
Cosine?
Positive.
Tangent?
Negative.
Secant?
Positive.
Cosecant?
Negative.
Cotangent?
Negative.
Cosine and secant are positive, the other 4 are negative. There's your chart. Now, why is this useful?
So you can tell on the radio.
You only need to memorize quadrant 1 of the unit circle. By making use of that table and reference angles, you can get every other quadrant just in quadrant 1. So again, you're cutting your work by 75%. So again, that table you may want to keep handy as well. And when I do trig, that's typically how I do trig. I just know the first quadrant, which, if you know the first quadrant, those are the acute angles. Then use reference angles and that table to decide values. So keep that table handy as well. Next set of problems, we're going to be given circle with a terminal point and ask you to find the value of the 6 trig functions. They also tell us it happens to be on a unit circle. So it's on the unit circle, what is R? Well, that's true, but what's the value of R? What's the radius of the unit circle?
Undefined.
That's a radius.
Huh? Just say it on a unit strip. The picture.
Doesn't show on there because it's understood what the radius is. Should have been discussed in geometry, but that was just such a hard course that if you left it out, I don't blame you. Radius is 1. Oh, okay, well that means we can just basically ignore R because it's 1. Sine, because radius is 1, is just the y coordinate. Cosine, because radius is 1, it's just the x coordinate. Tangent, y over x. 1/2 divided by negative root 3 over 2. Simplify that. Negative 1 over root 3. Yes. So why do I have here is root 3? Thanks, I messed that up. Right, or if you want to rationalize that, negative root 3 over 3, they're the same thing. Secant, 1 over x. Again, because radius is 1. Negative 2 over root 3, or if you'd like to rationalize, negative 2 root 3 over 3. Cosecant, 1 over the y coordinate. So reciprocal of 1/2, 2. over y which is just negative root 3.
So everything you needed to know for this problem was given to you on that thing? It's just like,
You just have to know the definitions of the 6 trig functions on a circle.
it's just like reorganizing them,
Not really reorganizing,
or like just like,
just knowing what the trig functions, how they're defined on a circle. And actually, it doesn't just have to be on a circle, right? Really, it's any point on a plane. If you just draw a line segment from the origin to that point, it's going to form an angle, and you can find the 6 trig functions.
So once we know all the functions to those, it'll be more easier. That's what you're saying.
What do you mean?
Like sin, cos, tangent.
Well, if you know how they're defined,
Yeah.
it's easy. Right? Sine y coordinate divided by radius, which is distance of the segment, length of that segment. Cosine is the x coordinate over the radius. And then from there, just use the fundamental identities. Tangent sine over cosine, secant 1 over cosine, cosecant 1 over sine. Cotangent is cosine over sine, or 1 over tangent. I'm actually going to use that here. Again, unit circle. What is sine? So for this problem, it's what? What's the value of sine?
oh, negative 2, or the square root of 2 over 2.
What about cosine?
Negative, the square root of 2 over 2.
Tangent is sine over cosine.
So it'd be
They're equal.
1.
Secant is 1 over cosine. Reciprocal of cosine. Cosecant is 1 over sine. The reciprocal of sine.
So it'd be the same thing.
Cotangent, 1 over tangent. Reciprocal of tangent. There's your 6 trig functions.
Do you want us to like do the like would we get like one thing off when we didn't like do the reciprocal or something?
What do you mean?
Like we just plugged it into the formula or
No. It's the same thing, isn't it? It's just using the fundamental identities can make your work easier. And you may as well practice them now because we are going to be using them a lot later.
Is this stuff going to be on the test tube? One, that's one, or
Right, what's your y coordinate?
So 2. Oh, the square root of 3 over 2. Cosine is -1. And
Tangent, sine over cosine. Right,
negative
so root 3 over 2 divided by -1/2.
square root of 3.
Negative square root of 3.
Mm.
Secant, reciprocal of cosine. Cosecant,
Square root of 3.
is reciprocal of sine. So 2 over root 3, or 2 root 3 over 3. Cotangent is the reciprocal of tangent. Right, -1 over root 3 or negative root 3 over 3. I will not deduct points if you don't rationalize or if you do rationalize, unless you do it wrong. And if you rationalize incorrectly, I should lose points.
What's the non-rationalized version of that?
-1 over root 3.
Okay, so that wouldn't matter if we put.
You can leave it like that, that's fine. It's just customary in mathematics, again, if you're dealing with numbers, to rationalize it. If you're dealing with expressions, typically you wouldn't. You leave it as 1 over root x, not root x over x.
Negative square root of 2 over 2. Square root of 2 over 2. It's sine over cosine.
Mm-hmm.
It's going to be negative.
You were thinking it.
1.
-1.
Yeah.
Right, the magnitudes of sine and cosine are the same.
That's a little early. That's R over sine. So square root of 2.
Root 2. Inverse of, or not inverse, sorry, reciprocal of cosine.
Wait, so we're going to rate?
It's root 2. Cosecant,
Negative square root of 2.
reciprocal of sine. And cotangent.
Negative 1.
-1. Sine,
0.
cosine,
Negative 1.
tangent,
0.
secant,
0. Or no, negative 1.
cosecant,
0. Wait, that's reciprocal of 0.
what's the reciprocal of 0?
Negative 0. 1/2. Square root of x.
Square root of 1.
t? Negative t.
What's 1 over 0?
Yeah. What? Over 0 is 0.
What's 1 over 0?
Zero over it.
0 over 1? Or 1 over 0?
Well, 0 over 1 is 0. What's 1 over 0?
The 1 to the square root of 0.
There's no reciprocal in it. There's no answer.
It's undefined. Not allowed to divide by 0.
Yeah.
What's cotangent?
0.
Negative 1.
Undefined.
It's undefined.
Awesome.
Wait, that's cosine over sine, right?
Yes.
Yeah, because you can't divide the 1, negative 1 by 0.
Or reciprocal of tangent.
So on the test, if we write 1 over 0, that's undefined.
You have to tell me that's undefined.
Oh, okay.
Right, because you can't do 1 over 0. Right, so you put like 1 over 0 and then say undefined, because then that's fine. You just leave 1 over 0, get some credit, but you won't get full credit. And then, of course, you have to give us some decimals and approximations.
Sine, that's going to be
What sign?
negative 0.596.
What is cosine?
0.803.
What is tangent?
Negative 0.596 or the opposite way around. It's going to be 0.8.
No, you're right the first time.
Why would you say it?
Because I was waiting for you to finish it.
Yeah, the point negative 0.596 over 0.803.
Which is what?
1.
You need a calculator. Unless you're really good with decimals,
Wait, but
which I'm not. I vaguely remember the process of long division with decimals.
if the point is on the radius, wouldn't that just mean it's 1?
Remember, the radius is just the length of that segment, which is 1. Well, in this case, it may not be exactly 1 because of the rounding. And remember your sig fig rules from last time.
That's going to equal negative 0.742.
Like 0.742, 3 sig figs. Again, I actually shouldn't really be using equals here. These are all approximations. But I'll go with just equals. Secant.
Oh, wait, also for the test, would you like want us to write out like I feel like if I were to do the tangent one, if I were to do like tangent t equals like cosine t over sine t, or not sine t over cosine t, would you want us to like show that and then put the number?
That's up to you.
Okay, because
If you're not gonna show it, just make sure you type it in right. Because if you get the wrong answer,
I'm not going.
I can't determine, did you not know what tangent was, or did you just calculate it wrong?
yeah, because my engineering teacher, he always tells us to write like the thing out so that you know. That's what we do.
So that's why I said it's up to you, but if you want partial credit, you show as much work as necessary to show that you know what you're doing. Right, you lose, for me, you lose less points for calculation errors than you do for not understanding the definition. Right, so if you understood that it was sine over cosine and you just calculated that value wrong, you might lose, depends on how many points, like if that part alone was worth 2 points, you might lose 0.25 for a wrong calculation, but you at least knew what tangent was. For an engineering course, I'd be doing it a little differently. Engineering, I'd actually take off a lot of points for miscalculations, because people's lives are at risk at that point. You don't calculate something correctly. But math is more about the understanding than the calculation. Physics is kind of the same way. We don't really care so much about the calculations in physics as much as trying to get a grasp on how the universe works. But engineering is completely different. You need accurate calculations. Otherwise, you're going to kill someone. Or multiple people. Like the rocket blowing up because they didn't convert the right way. Killing 4 astronauts. And no one got in trouble for it.
That's crazy.
Yeah, I think that's a little...
And astronauts don't even get paid that much, right? Your salaries are like $90K a year.
I'm not sure how much they make, but it's not enough.
Like that's insane. Like they should be like million.
Like those 2 that were left on the space station for 9 months.
That's what I'm saying. They should be paid.
They should be getting some overtime on that one. They're only supposed to be up there for a week.
Yeah, but they didn't.
No, they don't.
That's crazy.
Although I think their medical bills are covered. Because they had to go through a lot of testing to how long they were up there. If you notice, they're carried out because their muscles probably atrophied. So they don't even want to risk it. They just carry them out and take them right to a hospital. Hospital might be the wrong word. The medical station in NASA to examine them. And they're probably going to have to relearn how to walk.
They should be
Oh, you're in 0G for 9 months, where you're literally not walking. You're going to have to relearn how to walk. And you have to re-strengthen your legs so you can walk. And a lot of people don't understand the effects that 0G have on the body.
But they should just like put like an elliptical or something up in space so they can work out.
Well, the problem is, it's still in 0G.
It's not bad.
The ellipse was also going to be floating around.
What if it's like screwed down?
How are you going to stay on
Then?
it? You're in 0G. It's almost as bad as higher G's for the body.
Like
Low G and high G are very bad for the human body.
where do you find the difference? Like on like a different planet or something?
Not just that, quick acceleration,
Oh, like F1 drivers?
but the rocket acceleration, I think that's 5 G's of force on the body.
Or
Pass
like,
out. You can pass out without training.
or like those fasting military jets? I heard like
I don't know if they put as much G-force as a rocket, but yeah, you're also gonna have G-force on that.
Yeah, I heard that like people like
And you can pass out from it, yes.
yeah.
And it's the G-force that causes you to pass out. What's even?
Wait, now I just forgot the thing. Is an R over
cosine? It's the reciprocal of cosine? Or r over x? Amazing things.
1.3 or 1.24, 1.25.
Depends on the rounding method that you use. It's either going to be 1.24 or 1.25.
Yeah, I'll do
Right,
it.
I go 1.24 because what comes after that 5 is a 3. But if we're going to stick with the convention, it's going to be 1.25. Cosecant.
Under 5. Negative 1.68.
Cotangent.
Negative 1.35.
There's are your 6 trig functions for this circle. Or not for this circle, for this angle. I'm trying to get the idea, so let's skip out to 12. And come back if time allows. Sine of 3 pi over 4 times cosine of 5 pi over 3. First, at least for this one, I'll just go right off the unit circle. And then maybe for some future ones, I'll kind of show you my thought process. Sine of 3 pi over 4. Right, so you look on the unit circle. We'll look for the angle 3 pi over 4. Right, so it's this ray right here. Sine is the y-coordinate. Sine of 3 pi over 4 is root 2 over 2.
Can you explain that one more time?
It's just the y-coordinate. Right, so you go to the ray that has the angle, 3 pi over 4. Sine is the y-coordinate,
Okay.
root 2 over 2.
So it'd be root 2 over 2 times, and then 3 pi.
Back to the unit circle. 5 pi over 3.
That is to be seen
Down here.
So that's going to be the what x value.
Yeah. Cosine's the x-coordinate, 1/2. Root 2 over 4. And they say trig is hard. Ah, yes, okay, so let's fix that, because that's clearly not right.
How's that long? It's not long, the unit circle?
Cosine of equals pi over 6. Should clearly be negative. I'm going to walk through my thought process here. I would actually
Not use the unit circle.
I would actually just immediately find reference angles from here. I'm going to use the even and odd properties first. Sine's odd. Sine of negative 9 pi over 4 is the same as negative sine of 9 pi over 4. Right? F of negative x equals negative f of x. That's what it means to be odd. Cosine is even. That's just the same as cosine pi over 6. Oh, 9 pi over 4 is larger than 2 pi, right? Find the coterminal angle. Subtract 2 pi from 9 pi over 4. You get pi over 4, right? Those are both acute angles. I don't need to worry about finding reference angles. I happen to have that unit circle memorized. So I know sine pi over 4 is root 2 over 2.
30 degrees.
Cosine pi over 6 is root 3 over 2. And just do the product. Negative root 6 over 4. And that's what I would do in my head. That's my thought process.
But if you just want to take unit circle,
Well, negative 9 pi over 4 and negative pi over 6 are not on the unit circle. So you still have to kind of understand coterminal angles. Right. What you could do is just do this.
add them.
Negative 9 pi over 4, you know it's going to be one full revolution clockwise, and then pi over 4 down. There's negative 9 pi over 4. Negative pi over 6 is going to be a clockwise rotation of pi over 6. Boom, there's pi over 6. There's negative pi over 6. That's how you have to do it. Right, the easiest thing to do would just be use coterminal angles. Because remember, your cosine, your sine are 2 pi periodic as well, which is, of course, the coterminal angle business. Sine of 7 pi over 4. Reference angle of 7 pi over 4 is pi over 4. Now, what quadrant does 7 pi over 4 fall in? Well, it's just short of 2 pi. 7 pi over 4 is quadrant 4. Is sine positive or negative in quadrant 4?
Negative.
Negative. Sine of 7 pi over 4 would be negative sine of pi over 4. Reference angle from negative pi over 6 is pi over 6. What quadrant is negative pi over 6 in?
The fourth.
Fourth quadrant. Right? It's a clockwise rotation pi over 6, so it just drops down to the fourth. Is cosine positive or negative in quadrant 4?
Negative. In quadrant 4?
Quadrant 4 is positive.
Oh,
Which, by the way, that is just the even property of cosine. I know what sine pi over 4 is, I know what cosine pi over 6 is, so I'm done. It's the same as the last one. Actually, those are the exact same angles as the last one. No? Going to use the even property on cosine.
even property, you just changed it to positive?
Cosine negative, so even f of negative x equals f of x. So I can just drop the negative from the pi over 6. I know cosine of pi over 3. I know cosine of pi over 4. Cosine of pi over 3 is 1/2. Again, you can read that right from the unit circle. Cosine of pi over 4 is root 2 over 2. Root 2 over 4 is their product. What's on the pi?
One. 180. Zero.
It's 0. Pi is the negative x-axis. Your y-coordinate is 0. And 0 times anything is 0. That was easy. And so that's just reading it off of the unit circle. And so that first set of problems was just reading a circle, right? And understanding the definition of your trig functions. This second set was just reading the unit circle. And obviously using your knowledge of some of the basic properties, even, odd, coterminal angles, reference angles. Now my favorite types of problems. We're being told that sine of a certain angle t is 1/2, and that t is located in the second quadrant. We're being asked to find the value of the remaining trigonometric functions of t. I'm going to draw this in standard position. Which means we're starting at the origin, we go out to some terminal point. T is located in quadrant 2, which means the terminal point is located in quadrant 2.
It's gonna be 1 now.
It's going to say it's right there. Two ways to approach the problem. I could let R be 1, consider the unit circle. Or sine of t, how is that defined? Y over R. That length is 2. The y coordinate of the point is 1. Find the x coordinate. What's the distance formula?
So the distance is 2.
Right, what's the distance formula? Is that from algebra? Distance between 2 points? Oh wait, what's our initial point? It's a point, so it has to be an ordered pair.
2.1. Initial point?
Initial point. Where does the line segment start? The origin, 0, 0. But distance is r. 0, 0 is the origin, x, y is your terminal point. There's the radius. Oh, but wait a minute. Square root of side, x squared plus y squared equals r squared. Which, isn't that the relation for a circle of radius r? Send it at the origin. Solve for x. Because that's the missing point.
4. Oh, no.
Because it would be, x squared would be r squared minus y squared, right? So I'm just going to write it out for this one. I'm going to say x squared plus 1 squared has to be 2 squared.
So it's 1 squared.
X squared plus 1 has to be 4. X squared has to be 3.
Yeah.
Square root of 3?
What do we know about quadrant 2?
Both of them are negative.
Both of them are negative.
Yeah, x is
negative.
So it has to be a negative.
X is negative root 3. Because we're in quadrant 2. How is cosine defined?
X over R.
X over R. X is negative root 3. R is 2.
One over negative square root 3.
negative root 3 over 3. Reciprocal cosine is secant. Cosecant is the reciprocal of sine, which means in this problem cosecant was a freebie because they told you what sine is. Cotangent is the reciprocal of tangent. Which means you get a question like this on a test or a quiz, one of your answers is free.
So,
In this case, cosecant is free. So if you get cosecant wrong, you're going to make me very sad. Right? You're going to be very sad.
so basically, it says like, the problem says given sine t equals 1/2. So what you did to get the line, you just did like a rise over y, like x over y, for like.
Sine t is 1/2. Sine is y over r. Y coordinate over the length of the segment, or radius of the circle. So again, that's what I said, there's two ways to do it. You could treat radius as 1, in which case your y coordinate is 1/2. But now you're dealing with fractions and squaring fractions. It's a little more hideous. So I treated it as circular radius 2. So I treat my r as 2, which means my y coordinate is the numerator 1. And then went from there. Tangent's -2. T is in the fourth quadrant. And we're in the fourth quadrant. Our terminal point is going to be somewhere in the fourth quadrant. So let's say it's there. And that's our angle T.
Tangent,
How is tangent defined?
sine over cosine, so x over y.
X over y. What's the x coordinate of this point?
That's what I just don't get, like, is that -2?
What do you know about x in quadrant 4?
Positive.
That has to be positive. So what's x?
Positive.
What's y?
Negative
Negative what?
2.
What's the denominator of -2?
1.
Oh, actually, I messed that up. Tangent's not x over y. It's y over x. So it'd be 1 -2.
Okay.
We don't know what r is, but we can find it.
So you're doing that, like you took -2 and you put a 1 under it,
That's what it is, right?
and then it's y over it.
Mhm.
You could put that.
And you also have to use your knowledge that's in quadrant 4 to know which one's positive, which one's negative.
Yeah, that's how I thought, like you were doing, you did the other one, but you did the other one different, right?
It's the same one, except there was a different trig function. It was sine, which is y over r.
Oh, okay.
1 squared plus -2 squared has to be r squared. R squared is 5, right? What's r? It's just root 5. R is a length.
And length can't be negative?
Right, which means it has to be positive. R is always positive. Right, because you can also think of R instead of a length, it is, but think of it as radius of a circle, and radius has to always be positive. Right, so that's what you have to remember. R is always positive. It's only X and Y that can be negative. Oh, well, we know that's why we have R, we can find all the trig functions. Sine is Y over R.
So negative 2 over square root of
Cosine,
1 over square root of
X over R. Tangent, I don't need tangent. Secant, reciprocal of cosine. Cosecant
square root of 1 over
is reciprocal of sine. Cotangent, get your freebie here, so reciprocal of tangent. And so you should notice that in the actual finding of the values, I'm not using the definitions, I'm using the fundamental identities. I only used the definition for tangent to find my point. So it doesn't matter, right? You don't have to use the fundamental identities, you can use the definitions. Here we're told that the terminal point for angle theta is 3, 4. We want to determine the value of all 6 trig functions for theta. Again, start by drawing the angle in standard form. The point, P, what quadrant is that in?
1.
It's in the first quadrant. So I don't know, it's going to be, let's just say it's there.
You need to find that angle.
No, we want to find all the trig functions at that angle. I don't need to know what the actual value of the angle is. And right now we can't do that. We will determine that angle. That won't be till after the exam. Once again, we don't have R, but we can find it.
By doing the square root thing.
Right. X squared plus Y squared equals R squared. 3 squared is what?
9.
4 squared is what?
16.
What's 9 plus 16?
25.
So what's R?
25. No, square root of
Which is what?
5.
Oh, that's a 3, 4, 5 right triangle, by the way.
Root 4, 5.
Yes, I'm not at right triangles yet, but same thing. I can actually make that into a right triangle,
Yeah, by drawing the line down.
but we'll get to that later. What sign?
It's a 1. That's a 4 over 5.
What's cosine?
3 over 5.
What's tangent?
5 over 3. 3 over 5. Oh no, 4 over 4 over 3.
Yeah, Y over X. What is secant?
The reciprocal equivalent.
Which is what?
5 over 3.
Cosecant.
Reciprocal sine 5 over 4.
cotangent.
The way we were before.
Yeah. Is this difficult? Let me see. Trig gets a bad rap. Now I'm going to mention at this point, this is trig on a Cartesian plane. So flat. Is the universe flat? No. The universe is spherical.
There's 3D,
So actually, all of this is incorrect.
4D.
We should be using what's known as spherical trig, which is a whole different subject.
So this is like 2D trig, but like we should be doing like.
Well, it kind of works the same way even if it's 3D, as long as it's still in rectangular coordinates. The Cartesian plane, which is a flat. But you should never actually be working in Cartesian, because even the Earth is spherical. So the Earth itself is curved, so you should always be working in spherical coordinates. Right, so all physics as you're being taught right now is a lie.
So basically,
It's just good for short distance problems. Right, because for a short distance, you can treat the curvature as
it's straight.
zero, so it's flat.
But for a few miles, it's still like straight.
Actually, even a few miles, though, you do have curvature. Right, go on a flat road. Look up, just look straight off. Do you see the road continue on forever? Because at some point it curves downwards. While there are parallel lines are the line. In spherical, there are no such things as parallel lines. But that is advanced geometry. That's a junior level. If you take junior level geometry, college geometry, you'll learn about two coordinate systems in particular. You'll learn about hyperbolic geometry and spherical geometry. If you take Calc 3, you'll learn the cylindrical and spherical coordinate systems. Calc 2, you'll learn the polar coordinate systems.
Polar
Coordinate system.
and rectangular.
Well, you're working rectangle right now. The Cartesian coordinate system that you learned in geometry is the rectangular coordinate system, which is what we have been working in.
Because like in engineering, there's like a polar notation or
Yeah,
rectangular
that's the
notation.
polar coordinate system.
Oh, okay, yeah, because we learned that.
Yeah, you'll learn more about that in Calc 2. You'll study that. Which means you're also going to be working with spherical and cylindrical, depending on your engineering branch. If you do mechanical, definitely cylindrical, electrical, spherical. You don't actually have to worry about that. But you have to take Calc 3, so you'll learn it anyway.
It's going to be the second coordinate.
Let's say the point's right there.
It's going to be the same thing. No.
No, it's going to be close. R once again is going to be 5. What sign?
Negative version.
So here I'm actually going to cheat.
Oh, you just need to change the what's it called? The sign.
And this is what I call instructor's prerogative. I don't have to rewrite anything. I'm just going to copy and paste. Because there's only 4 values that are going to change, and they're not going to change by much. We're in quadrant 2, right? Which means sine and cosecant stay positive. Everything else switches to negative. And so just so I don't have to rewrite everything, I'm just going to copy and paste and put negatives. Where's this point located?
Our
To the third.
So maybe right there.
Or just go to the 10.
R is root 10. What is sine of theta?
Negative 4 over square root of 10.
What is cosine of theta?
negative square root of 10 over 10.
What is tangent?
Negative 3 over 3.
Negative 3 over negative 1.
Which is just 3. Right.
Oh, yeah, you probably did.
Secant?
Square root of 10 over 1. Negative. Square root of 10 over 1. Okay, 10.
Cosecant?
Negative square root of 10 over 3.
And cotangent?
Negative 1 over 3.
1 over 3.
1/3. Be negative 1 over negative 3. It's just 1/3. We can do this all day.
What was that one question that we skipped?
I skipped a few, but it was just reading from a circle. They want us to find two values here, cosine and tangent. They tell us that sine is 8/17 and that theta is located in the first quadrant.
We could just get a similar. And that's rise over 1, right? So that's x over y, so x would be 8. And
I do agree with definitely in the first, well, they tell us from the first quadrant.
or is it rise over 1? Oh, rise over 1 is y rise, right?
How is, correct, how is sine defined?
1.
It's y over r. So the length of that ray is 17. The y equivalent to the point is 8. Find x. So what is 17 squared minus 8 squared?
$225.
225. 17 squared, is that 349?
$289.
289, yeah. What's x?
Square root of 221.
Which is what? It's 15.
Yeah.
And it's positive, right, because we're in quadrant 1. Oh, good. We have all the information we need. What's cosine?
Cosine is a
15 over 17.
And what's tangent?
8 over 15.
There you go. They just want to cosine tangent for this problem. So you're done.
Is the test going to be this easy?
Well, remember, the test doesn't just cover this stuff.
So everything up until logarithmic, or logs in general are going to be on the test? Or
So everything up until Tuesday. Or, sorry, Wednesday.
Up until this Wednesday?
Will be on the second exam. So it's rational functions, all of the exponential and logarithmic, and the first part of trig, the first 3 sections of trig. Angles, this stuff, and then what we do on Wednesday, which is right triangles.
So that's worse.
That's all on exam 2.
Exponential, logs, and the
Rationals, right, because we did rational functions after the first exam. Then all of exponential and logarithmic, and then this stuff on trig. We're given that cosine of theta is 5 over 6. We are not told where theta is located, though. So where could theta be located? Right, where is cosine positive?
Quadrant 3. Before
And where else?
first.
Theta is either in the first quadrant or the fourth quadrant. We don't know which one, so we have to consider both scenarios. How is cosine defined?
y over x over
X over R.
Cosine. So you can solve for y. And then you'll just have everything.
-36 minus 25.
11.
Y squared is 11.
Square root of 11.
Nope. Absolute value of y has to be square root of 11. Because we don't know what quadrant we're in. So we don't know if y is positive or negative.
So does that mean you have to do plus or minus sign? Plus or minus sign?
Let's assume first that we're in the first quadrant. Then y is just positive root 11, right? Because in the first quadrant, y is positive. What is sine theta?
Y over 4. So square root of 11 over 3.
And what's tangent?
Do you have to do that for each quadrant?
Well, we don't have 2 possible quadrants. Because cosine's positive, which limits it. Limits what we can do.
And you have it,
That is if it's in quadrant 1. If instead we're in quadrant 4, y is negative square root of 11.
So it would be negative.
So the answer could be plus or minus.
Depends on the quadrant you get.
And why wouldn't it, why don't we have to do quadrant 2 and 3?
Where's cosine positive?
That's the,
What quadrants is cosine positive in? First quadrant, fourth quadrant. That's why we like to consider 1 and 4. Because they told us that cosine is positive, right? Cosine is 5/6, that's positive. So we only could be in 1 or 4. We can't be in 2 and 3. Tangent theta is negative 3/4. Find sine and cosine. Once again, they don't tell us what quadrant we're in. But we do know that tangent is negative, right? Where is tangent negative?
that goes back to the chart we did, right?
Mhm.
That's what you're flipping back to.
Like I said, it's a pretty important question. That might also be something you want
Right on
to put down on the sheet of paper with where all your properties are. Or maybe, on the reference sheet for the exam as well. Just maybe a hint. We again want to consider each case if we're in the second quadrant or the fourth quadrant. But first, oops. Right? Tangent y over x. So absolute value of x is 4, absolute value of y is 3. Right? X is either plus or minus 4, y is plus or minus 3. What's r then?
It's 5.
R squared is 25.
It's 5.
R is 5.
It's 3, 4, 5 triangle.
And we know that R is positive. Because R has to be positive. If we're in quadrant 2, is x positive or negative?
Negative.
And what about y?
Positive.
So then it would be sine would be.
So it's just like that last question, plus or minus.
Sine would be 3/5, cosine would be negative 4/5. If we're in quadrant 4, is x positive or negative?
Positive.
What about y?
Negative.
Sine would then be negative 3/5, cosine would be positive 4/5. They just want sine here. They tell us that cosine is negative 4/5 and that tangent of theta is greater than 0. Cosine is negative. What quadrants is cosine negative?
2 and 3.
Of those two, which one is tangent positive in?
2, 3.
Great. We're in quadrant 3.
Because it's greater than the other.
Right, cosine theta being negative and tangent theta being positive means we have to be in quadrant 3. X is -4, R is 5, right? Cosine is X over R. So what is Y?
30,
Mm-hmm.
negative 3.
-3. Because we're in the third quadrant. Then what's sine of theta? -3, that's right. So a lot of these questions don't require any calculations. It's really a conceptual type of thing. Do you know your trig functions and how is it defined? Do you know your coordinate plane? Where x is positive or y is positive, right? Here we're given two values. Sine is √3/2. Cosine is -1/2. Find the remaining 4. Well, 2 are freebies. Actually, they're all freebies.
Do we have everything?
I don't need to worry about anything else. Because all 4 trig functions, the remaining 4, can be defined in terms of sine and cosines. What's tangent? I wouldn't use y over x. Sine or cosine.
Oh,
√3/2 divided by -1/2.
yeah.
-3. Secant is the reciprocal of cosine. Let me write that out.
Negative.
Cosecant is the reciprocal of sine. So 2 over √3, right? Cotangent can be written one of 2 ways. I'm going to use this way because I already have tangent. It's the reciprocal of tangent.
Negative 1 over the square root of 3.
There's, you're missing 4 trig functions. Could you have set up your coordinate system like we did with the previous ones? Yes. You have all the information. R is 2, y is positive √3, x is -1. Go from there. But using the fundamental identities save you time. Questions on the trig functions of a circle?
This is known fluxes. Once you know that, it's really
Well, that's what I said, and that is worth it. If you just know sine and cosine, know how reference angles work, know how cosine angles work, know that table that we did at the very start, and memorize the first quadrant, you're done. Trig will take you, each of those questions will probably take you 5 seconds.
I remember so we had to memorize the whole unit circle, but I forgot it.
Yeah, I don't make you memorize.
Yeah, that
But memorization does help.
yeah.
Right, so you don't have to, but it certainly helps. So homework on this stuff, we do the 7th, and I actually cut the homework down because originally it was like 60-something questions. I got to way too much. So it's still quite a bit. I think it's in the 40s for this one. But a lot of them are going to be like circles. Like here's a circle. What's on cosine? Right. So it's a lot of just read the circle here, here it is. Right, a lot of it is what we did in class, right? And I'm sure those types of questions. I think there's a couple applications on there that might be. Right, so take what we did in class and apply it to a new situation. So yes, a lot of questions, but a lot of them shouldn't take you long. Second exam, don't forget, is next Monday. That will cover everything we do up through Wednesday. And the third quiz will be available in about 8 minutes, and that will be due on Wednesday. And that only covers, again, what we did since quiz 2 until today. Right, so whatever we did right after quiz number 2, I forget what that is, right up to today's stuff. That'll be on quiz 3. No units are always provided for quiz 3 because stay home, so it's open notes. So maybe print out the slide with the unit circle on it before you start the quiz, so you have it readily available. Wednesday, we will look at the trig functions on a right triangle, right? So, like I said, there's 2 ways to look at trig. You have what's known as unit circle trigonometry. Circle trigonometry is what we did today, and then right triangle trigonometry, which we do on Wednesday. And personally, I like the right triangle better.
Yeah, that's like X.
Right triangle trigonometry is my favorite. That's how I do trig. I do everything in terms of right triangles.
That's not good.
But there has to be conditional data to use right triangles. It has to be an acute angle. So technically for like 5 pi or 3 or whatever, you can't do it. But you can finagle it if you know reference angles and that chart that we did. So you can get around it. See you on Wednesday.
You took